Okay. Hello, everyone. Thanks for showing up in a great number, considering this is the last day of the conference. I'm Himanshu, and I'm here to present our work, Conceptualizing Disagreement in Qualitative Coding, which has been a fruitful result of collaboration with my amazing co-authors. That's Meg, Bonnie, Lou, and Cecilia at the University of Washington. So before we dive deep into the presentation, I just wanted to have a quick show of hands. How many of you at some point have been involved or at least have heard of what qualitative coding is? And I'm going to raise my hand. Wow, that's a great number of hands. Thank you. So for those who do not know what qualitative coding is, I will use a simple layman language. It is the process in which you use labels assigned to data so that you can categorize it and you can make sense of it for the purpose of analysis. Now, what does it exactly mean? Let's look at a small example sentence, which, by the way, is hypothetical. Now, let's say you asked 4 different coders to actually look at the sentence and label it based on what sentiments does it convey to you. You can have several. You can have a group of people who think that it's probably about sadness, it probably invokes frustration. You can have other users who think maybe it's anger, dislike, and several more. What is important here is that it is really difficult to have different people have a consensus in terms of what label is appropriate for that one data instance. When we do not have such a consensus, we have ambiguity in terms of the call coding. We refer to this instance of ambiguity as disagreement throughout the talk. And resolving disagreements is actually a very tricky business. And it's also very time consuming. It's very tricky because it often involves the role of an arbitrator, and it is that one arbitrator who always decides if of label A and label B, which one is going to be more appropriate to be assigned for that one data instance. It will be so much nicer if instead of having the authority of the arbitrator, if we could split that authority amongst all the participants who were actually involved in coding. The second is qualitative researchers use a lot of tools to help them and to augment the process of qualitative coding. And they do help. They help a great deal. But there is still scope of improvement. Imagine this. When people who use sophisticated visualizations to help them in the process, we have instances in literature where 8 coders spent about 8 to 10 weeks coding and resolving the disagreements of data. And even then, they could just reach like 5%. That's like a long way for us to improve upon. Beyond that, there are also several techniques which have been devised and which qualitative researchers often use in their coding, which may not necessarily help us the way we want to. To cite one, I would say something like iterator reliability. We often use that. But iterator reliability offers an insight into qualitative coding at a very aggregate level. It gives us an understanding over maybe 100 data instances or 200 data instances. What really happens at each coding level, and how do we identify how does that distribution of coding for one data instance associate with the general coding scheme? There are further things in qualitative coding. It's very dependent on subjective judgments of individuals. At the same time, it is also very dependent on the context involved of coding. So if I have to do qualitative coding with some other person, there is a huge aspect of learning involved because we have to make sure that we share the same context. Now, we use this opportunity for our work and try to offer a computational lens to think about what collective disagreement actually is. Will it not be great also if we could have a measure which we can use to rank the collective disagreement? For doing that, our approach focuses on the human-centered idea. We want to make sure that our approach, while helps the qualitative researchers in their existing practices, we do not want to force the qualitative researchers to actually move away from what they are already doing, or we do not want them to go and learn something new. We want to make sure that the techniques help them, they augment their efforts, and not take away from what they're already doing. We offer 2 metrics. The first one is a top-down approach of disagreement, in which we look at disagreement and we try to decompose the collective coding into smaller groups and smaller fragments. The second approach is an n-ary, we call that as an n-ary tree metric, but it is a bottom-up approach in which we start by looking at individual coding, and we slowly build on top of that as more and more coders come into the process of building disagreements. We test our approach using two populations. One is the mTurker population, which we understand is the non-expert coders population, and the second is our amazing PhD student colleagues who happen to be our expert population. In order to understand more about how disagreements can be decomposed, which happens to be the top-down view, we use a tree structure to computationally represent it. It looks something like this. What you see on the slides is a tuple 7, 3, which conveys the meaning that we have 7 coders who want to label the data, and we are trying to search groups of 3 people who agree on using the same label for coding that data. Now, you can have 2 options here. We can either find such a group or we can not find such a group. Let's say we do find such a group. In this case, we have decomposed the problem 7.3 into a smaller problem, which is 4.3, which means we are searching for 4 coders, again, such that 3 of them may have agreed on the same label for coding that data. Notice we are also assigning a small sequence of digits, 3000, corresponding to that node, which conveys that there is at least one group of 3 people who have agreed on using the same label. The other case in which we may not have found a group of 3 coders who agreed on the same label, in that case, the decomposition looks as 7.2 because we still need 7 coders since we did not find a group of 3 people who agreed on the same label. However, since we did not find a group of 3, we now only have the option to search for people who can agree together in pairs, in groups of 2. Now, as we go on building this tree, and which is also to say that we are decomposing the idea of disagreement further down, we get a much complex tree, which we are not really presenting here for the sake of simplicity. However, when we actually build the entire tree and we follow a certain order of traversal, which is for those who know, which is the post-order traversal of the tree, we find some obvious ordering in terms of how the disagreement can be mapped. The scale you see at the bottom of the slide is when you actually build the entire tree. The numbers on the left correspond to nodes which correspond to low agreement, that is high disagreement. And on the right side, you have a case of high agreement, that is low disagreement. However, this violates one thing. We started with the entire idea of how we wanted to have an approach which, instead of forcing the qualitative researchers to rank different states of disagreement, we wanted to preserve the nuance of qualitative coding practices. Now, this doesn't do that. This violates the ethos because it forces people to say that one state is at least lower or higher in terms of disagreement. In order to do that, we now look into our second approach, which is the bottom-up view of disagreement. In this, we start with the first coder coming and assigning one of the labels of the 4, A, B, C, D, to the data instance. We have the second coder. The second coder has 2 choices here. He can either agree with the first coder, or he can disagree with the first coder. We have the third coder coming in place now. Things get slightly interesting at this point of time because he can either agree with the majority, he can either disagree with everyone, or at the same time, he can also choose to assign a separate vote but not agree with the majority. We use indexing. We use the concept of indexing for each of these nodes, and then we have a small algorithm which uses the indexing, which processes the indexing rather, and we generate a ranking of these states of disagreements. Again, in the interest of time, we won't be going in the details of that. However, what is interesting and what is unique offering for this particular metric is the fact that when we have a fourth coder coming, notice how at this point of time, we don't really have the nodes branching in just 2, but we have nodes which are also branching into 3. Specifically focus at how the node 2100 has a connection, the one which is highlighted in red, with the node 2200. This is not just a case of adding an agreement or just adding a disagreement, but in fact both, which I think conveys the nuance of how the disagreements develop in qualitative coding. And we want to make sure that this is the highlight point and what we should learn from the second metric. Now, in order to compare how the two rankings given by the first metric, which is the post-order metric, and the n-ary metric, we conducted a quantitative study on mTurk. We had 50 participants. We assigned them 4 tasks. The tasks were to look at how the data was coded by the 7 participants, and they had 5 data instances. And we presented them the data in 2 formats. One was a table, and the second was visualization, as you see on the right side of the slide. The tasks were to relatively rank the different data instances in terms of how much disagreement is there in coding them, and we also asked them to do the same thing in terms of absolute scale. The findings indicated that the mTurk participants, who again we thought were to be the non-expert participants, their judgment of how disagreement works aligned better with the second metric, the n-ary metric, which captured the nuances better than the first metric. That made us curious what exactly happened. Why did this particular set of coders think that that was a better choice for them, and why did the alignment happen? We wanted to understand the strategies which these people used. And in order to get a deep dive inside, we conducted a second study with the expert qualitative coders, which, as I already mentioned, were the PhD colleagues in our case. All of them had some experience, in fact, tremendous experience in qualitative coding. We asked them to give us a walkthrough over how they thought about the entire process, and this is what we found. We found that most of the participants talked about having 2 different strategies. The first strategy which they mentioned about was having a majority vote. Now, we refer the majority vote as the divergence strategy. If you look at the highlighted data instance, you see how the divergence strategy works. The reason most agreement is like the one that has the strongest bar of one color. As you see, you have a very strong blue color for that particular data instance, and the participants who followed this strategy thought that, well, that indicates there's a high agreement. At the same time, we had some other participants who thought that it is not just about the largest number of people agreeing on the label, but it's also about the split of how the codes are distributed amongst the different possible labels. We refer to this aspect as diversity. As you see in the highlighted section, we have a data instance which has been coded using 3 different labels. Now that indicates this section of the other population, which use this aspect of distribution among different labels as the key idea to come to rank the disagreements. So in order to summarize the whole thing, our approach here and the metrics that we present augments the researcher efforts that goes in going through a coding scheme or through resolving disagreements. Often people use visualizations for the same purpose, and we anticipate that by using the metrics that we present, people can actually build even much efficient visualizations which actually help their efforts of qualitative coding. The other thing that we offer, which is a contribution of our work, is the fact that oftentimes qualitative researchers are trying to identify the similarities and the differences between the coding schemes when they are looking at 2 different data sets, or maybe at times even 2 different subparts of the same data set. And just by having different labels, often the capacity to identify the similarities or the differences is hindered. Our approach makes sure that it works without being tied, without being bound to a context. This is the main and the key aspect of our contribution, that we are offering the researcher the capacity to have a technique which adopts to their understanding, to their notion of what is more important when they are doing qualitative coding. If you are a person who believes that divergence is a key dimension to how you think about qualitative coding, we want to offer you a technique which works for you. If you think that it is not just about divergence, but also about diversity, then we feel that the second metric, which is the n-ary metric, which captures the nuance of both, is actually the right metric for you. So to drive down the take-home factor, I would say it's about having techniques which allow qualitative researchers to appropriate the meaning to what they really want from qualitative research and not the other way around. Having said that, I'm open for any comments, critiques, questions.
Hi, Ruben Binns from University of Oxford. Thanks for a really interesting talk. I wonder, there's another element maybe of disagreement which I think doesn't get captured, which is when you have a code that is applied when either there's, you need A, B, or C, where it says it's or one of those three, or when it's like two necessary conditions for a code to be applied. And in those cases, you might have reviewer 1 reject using that label because they think it's like the first condition but not the second. Reviewer 2 might reject using the label because they think the first condition doesn't apply but the second does. So they both, it looks like they agree, but their reasons for disagreeing are different. Do you think that's an element that should be captured in these things?
So just to rephrase your question, are you trying to ask like what happens if we allow each coder to assign multiple labels to the same data instance?
So if the labeling, if the criteria for applying a particular label is multi-step, so it's either you have to meet these necessary conditions or these sufficient conditions?
So at present, this approach does not really cater to that nuance because we are forcing each individual to like fix upon just one of the codes. However, I think the problem you are mentioning is actually a significant one because we often see qualitative researchers employ that when, especially in the generative coding process. And I think we can take care of that if we can adopt the mechanism to accommodate the idea of weighted labels. So a coder can specifically indicate that he is not just like giving 2 different codes, but having a weight assigned to one of them.
Thanks.
Sure.
Hi there, Eric Balmer, Lehigh University. I wanted to ask about the different functions that disagreement can serve in different styles of qualitative coding. So I'm thinking about the way that the approach you described is very much set in a paradigm where there are discrete units, a coding scheme has already been established, and coders are essentially applying that existing coding scheme to these discrete units. And you can contrast that to something like open coding of interview transcripts, right? Where you have the interview transcript and any amount of span of text can be annotated, and you're developing those codes on the fly, right? And I'd be really interested to hear you talk about how, because that's another place where you might have different annotators who are looking at the same data, annotating it, and then trying to talk about their differences, but you're not necessarily working toward agreement in an inter-rater reliability paradigm.
Absolutely.
And so I'd love to hear you talk about how you could adapt your approaches to that kind of paradigm.
Wonderful. Thanks for the question. It's actually a wonderful question. And I think I had a couple of slides trying to address that whole point, but I didn't go in the nick of time. I think one of the key elements which is also a limitation of our work right now is we are not really talking about an open coding process. We are looking at approaches where we at least have some idea about what the preliminary codes would be. Having said that, I suspect that the approach would work absolutely fine even for an open coding process. The limitation there would be that the tree structures, which are the computational representations we are using, would actually increase exponentially. But having said that, I would say theoretically the approach would still work. We would definitely need a lot of thinking and perhaps maybe a lot of sitting with qualitative researchers to how the approach would really work by having an open book exercise.
Interesting. Thank you.
Sure, thanks.
Thanks. We don't have any more questions.